Many of you want to do it, but something holds you back. And this is what I am going to teach you today. And I'm going to try and keep it as short as possible and give you the solution that I've got. And the solution is commendable, it's impeccable. And you're going to understand it very easily. But of course, nothing can happen without your effort. And you have to be dedicated and give it your best shot. And today's most important topic is conjunctive normal form. So this topic is from mathematical logics and this is related to MFCS DMGT. So now I'm going to explain what is a conjunctive normal form. So procedure and working rule of this CNF and two examples. See here, first of all, before going into this, so you have to learn about elementary sum. So what is this sum and what is this product? See here, when you observe this one, so this symbol generally denotes a sum and this symbol generally denotes product. See here, as you're very familiar with this, so this is disjunction. Clear? So this symbol is nothing but conjunction. Hope you got an idea. See here, this is related to sum and this is related to product. So this is nothing but disjunction and this is nothing but conjunction. First learn the terminology. And what is this elementary sum? See here, talking about the sum. See, the sum of the variables and their negations in a formula is called elementary sum. See here, what are the variables? The propositions P, Q, R and so on are all the variables and negation is the negative statement. See, let P and Q be the two atomic variables. If you take two variables, then see sum, it is represented by this symbol. See here, this is cup and this is cap. See here, the relation between these two, the sum of these two can be represented as P or Q. So this is negation P or Q and there P or negation Q and negation P or negation Q. See here, this is the symbol sum. Sum of the variables and their negations. Sum of the variables and their negations. See here, this represents a sum. So the symbol here, this one is sum between the variables or the negation of the variables and the variable. So these are all the possible sums for two propositions. So these are elementary sum. Why I am talking about this elementary sum? See here, what is conjunctive normal form? Conjunctive normal form is very easy if you understand this one. The product, a product of elementary sum. See here, when you make a product of these elementary sums, then this is known as conjunctive normal forms. See here, what are the product? The product is represented by cap or conjunction or and symbol. So if this product of elementary sums, see if you take two sums here, so there are two sums here, that is P or Q, negation P or negation Q, or in between these two if there is a product, so here, so this symbol is nothing but the product, or see here, this is nothing but the conjunction symbol, the conjunction between these two elementary sums. So just now I have taught what is elementary sum. So this is elementary sum. So this is also elementary sum. The product of two elementary sums. The product of elementary sums is called CNF, that is conjunctive normal forms. See clear? So I have said about elementary sum. So elementary sum is represented by, the sum symbol is represented by cup or disjunction. So between any two variables and their negations, these are all the sums. And it in between these two sums, if there is a product symbol, if you multiply these two sums, the product of elementary sum is called the conjunctive normal form. So example of this is, so this is a product of elementary sum is a conjunctive normal form, or so as this, if you see in between which symbol is there, conjunction is there, therefore it is called CNF. Now I am going to teach you or the process to solve CNF. So the procedure to obtain the CNF. So CNF means conjunctive normal form. First of all, we have to remove the symbol implication and double implication in the given particular formula. In an equivalent formula, we have to remove these two. The first thing you have to do. And next one, we have to eliminate this conjunction or disjunction by using double negations or De Morgan's laws, using all the equivalent laws. So we have to remove this and or. So first of all, we have to remove implication, double implication, and next one and or. And next one, we have to apply distributive law until the product of the elementary sums are obtained. If we get a product of elementary sums, so this is nothing but CNF. Clear? The procedure is also very simple. So wherever you find an implication, first of all, you have to remove using an equivalent formula, and next double implication also you have to remove using the equivalent formula, and next we have to eliminate and or by using double negations, De Morgan's laws, and on and so on. And we have to apply distributive law unless we get product of elementary sums. See, the product of elementary sums is nothing but the CNF. So this is how we have to do. And the first example here is, see, this is also the most important question. See, the first thing is negation of P or Q double implies P and Q. The first thing is we have to obtain the conjunctive normal form for the given equivalence formula. See, first of all, the procedure for this is, I have said you, so we have to remove this double negation. In order to remove this double negation, what we have to do? So we have to use an equivalence formula. So what will be the equivalence formula for this? So the equivalence formula for this is, so P double implies, see, this is the formula I'm going to use. P double implies Q is equivalent to, this is P implies Q and this is Q implies P. So this is the formula I'm going to use here. So I have to consider this as P and this as Q, and I have to apply as P implies Q and Q implies P. So instead of this one, so this is of the form P and Q. So if you consider this whole thing as one X and this whole thing as Y, so P double implies Q means P implies Q and Q implies P. Now I am going to apply this one. So this is P and this is Q. So this will be negation of P or Q implies, so this one is Q, that is P and Q. So P implies Q is done. Next one and Q implies P. What is Q here? This is P and Q implies, this one is P. Negation of, this is P or Q. Clear? And next thing here is we have to remove. So which one we have to remove? Implications, double implications, and after that we have to remove this implications. Clear? So for removing that implications, which equivalence formula I have to use? As you know, this is a famous formula, that is P implies Q is equivalent to negation P or Q. So this is the formula which I am going to use for both these. And this will be, so if you consider this as P and this as Q, this will be negation of, so this is negation of P and Q, or this is P and Q. Clear? And for this and, so this is P implies Q. So this will be negation P, or, so this one is Q. Clear? And the next thing here is I am going to send this negation inside. I am going to send this negation inside, this negation inside. So which formula I am going to use? De Morgan's law. So according to De Morgan's law, so if you send negation inside, so what will happen? Negation inside. So this is negation P, or will become under negation Q. Clear? So this is the formula I am going to use here as well as here. Clear? And see, if I send this negation inside, then this will become negation of. So this will be negation P and this is negation Q. And or this is P and Q. And next one here is, if I send this negation inside, this will be negation P. This and will become or this is, if I send this negation inside, this will be negation P and negation Q. Clear? So again, if I send this negation inside, so this will be again De Morgan's law, and this is going to become negation of negation p. If I send this negation inside, so this will and will become or. So this is, if I send this negation inside, negation of negation q, or, so this is p and q, and next one and, so this is as it is, this is negation p or negation q, or this is negation p and negation q. Clear? So this will be double negation. So according to the double negation law, according to our double negation law, so as you know that negation of negation p is equivalent to p. So negative negativity will become positive. See here, remember, so I'm applying double negation law here. So this will be p or q, or, so this will be p and q. Clear? And this will be negation p or negation q, or this is negation p and negation q. Clear? And see, now I'm going to apply this one, distributive law. If I distribute this one, so this p or q can be distributed. So this is distributed to this one and this one. So the negation p is distributed to this one as well as this one. And see, this will be, I can write this as p or q or p, and next one, this is and, this will be p or q, and next one, this is or q. Clear? So this and I have given here, and next one, this one, p negation p or negation q, this is or negation p, and there is an and symbol here. So again I have to multiply with this, negation p or negation q or negation q. Hope it is clear. So as you know that there is a same symbol here, p or p. So which identity have to use? Idempotent law. According to our idempotent law, p into p is equal to again p. If I apply this one, so here there are two p's here. I am writing a single p, that is p or q, and so here there are two q's, and here there are two negation p's. There are two negation q's. So I am writing for one time. So this is p or q, and so this is negation p or negation q, and here, and there is un symbol here, and this is negation p or negation q. See here, just now I have said that. So which symbol it is? This is sum. See here, this symbol is nothing but sum. See here, the sum of the variables and its negations is called elementary sum. So in between, what is there? Product. So this is a product or conjunction. So this symbol is otherwise known as conjunction. Just now I have said. So this is a conjunction, and this is a conjunction. So if you observe, so these are all elementary sums. So if you observe carefully, this is elementary sum, this is elementary sum, this is elementary sum, and this is elementary sum. Sum of elementary sums. See here. So this one, if you see, this is product of elementary sum. Sorry, product of elementary sum is nothing but product of elementary sum is called CNF. So this is conjunctive normal form. So this is a conjunctive normal form. So this is how we have to solve. First of all, we have to eliminate double implication using this one. So I have written this as P implies Q and Q implies P. And later I have to eliminate this one, that is the symbol implies. So using this one equivalent formula, that is P implies Q is nothing but negation P or Q. So negation P or Q. Next, De Morgan's law. So if you send negation inside, so this or will become and. See here, or will become and. So this or will become and. So wherever I find negation outside, if I send inside, so this or will become and will become or. So after that one, double negation I have applied here. And after applying double negation, so distributive laws. So these are the distributive laws after distribution. and using idempotent law, so I got all the elementary sums with a product. Therefore, a product of elementary sum is nothing but the conjunctive normal form. So this is the first solution I have given, and the second question here is P implies P implies Q and negation of negation Q or negation P. So if you watch this one, the procedure is also very simple here. As I've said you, first of all, we have to eliminate this one. Which one we have to eliminate? This implication we have to eliminate according to our process. And the next one, we have to use De Morgan's law, distributive law, whatever it might be. See, in the solution, I'm going to use P implies Q. So for P implies Q, what is the equivalence formula? So this is negation P or Q. So this is the most important formula. So as I'm considering this as one thing and this as one thing. So this is a whole bracket. So if I apply, this is P implies Q. So I'm writing this as negation P. So this is negation P. So this is only for one time. So this is negation P or Q. So what is Q here? This is P implies Q, and this is negation of negation Q, or this is negation P. Clear? And again there is an implication here. So there is again an implication. Again I am going to use the same formula, that is P implies Q, which is equal to negation P or Q. So for this negation P or, so this will be negation P or Q, and this is negation of negation Q or negation P. Clear? And in this I am going to use De Morgan's law. So if I send this negation inside, so which equivalent formula I have to use? This is De Morgan's law. So if I send negation inside, this or will become and according to De Morgan's law. So I am writing the same here, that is negation P or. So this is negation P or Q, and so if I send negation, this will be negation of negation Q, or will become and again negation of negation P. And next one, I have to use double negation law. So according to our double negation law, negation of negation, so it will vanish, and this will be negation P or, this is negation P or Q, and this will be Q and P. According to our negation law, negation of negation P is nothing but P, and negation of negation Q is nothing but Q. Clear? And after that one, what we have to use? So we have to give a distributive law here. So this is negation P is distributed to this one as well as this one, as this is the whole symbol. So I am going to apply distribution law. According to our distribution law, here negation P is distributed to this one as well as that one. This will be negation P or, this is negation P or Q. So this negation P is distributed to this one, and next thing here is and negation P is distributed to this one, negation P, or this is Q and P. And next thing here is this one I can write as associative law. Associative law I have to use. If I apply associative law, so I can interchange these brackets as negation P or, this is negation P or Q, and so this one, if I change this one, negation P, I can write this negation P. No, here I have to use distribution law. So this one I am applying a distribution law, and I am giving this negation P to both Q and P. So this is negation P or Q, and this is negation P or P. Clear? And this one, negation P or negation P, which formula I have to use? Idempotent law. According to idempotent law here, so this can be written as only a single negation P or Q, and so here this will be negation P or Q, and this is negation P or P. So here which law it is? Negation law. According to our negation law, negation P or P is equivalent to true. True. So this will be negation P or Q, and so this is negation P or Q and true. So according to our identity law, P and true is equivalent to P. So this is P and true. So this is equivalent to P. That is negation P or Q. And so this is negation P or Q. See, if you observe, so what is this one? So this one is a sum. So this one is a sum. The sum of the variables of negation statement and the variable statement is called. So this is elementary sum. This is also elementary sum. So the symbol here is nothing but the product or conjunction. See here, the product of elementary sums is nothing but CNF, that is conjunctive normal form. Is it very clear? So first of all, we have to eliminate this implication. So using this equivalent formula, this is negation P. So this is negation P or this one is Q. And after that, we have to remove this again implication. So negation P or Q. In place of this, I am writing negation P or Q. And next one, De Morgan's law. Wherever you find a negation, you have to send it inside. This or will become and double negation here. So double negation will go and it will be Q or P. And again distributive law. So this negation P is distributed to both the brackets here. And next one is associative law I've applied here. This is idempotent law. And if I give a distributive law here, this will be this one, and after that idempotent law, and later this one is also as a product of elementary sum. So product of elementary sum is nothing but CNF, and this is how you have to solve. So if you understand the concept, so what is elementary sum, what is the product of elementary sum? So this is nothing but the conjunctive normal form. So this is nothing but, see here, this is conjunctive normal form, CNF. So this is conjunctive normal form. The product of elementary sum is called a conjunctive normal form. This is the product symbol. This is the sum symbol. So you have to get a clarity on the symbols also. This is conjunction. This is disjunction. This is elementary sum. And hope I have given whatever the clarity which you need. That is elementary sum, product of elementary sum, conjunctive normal form, examples, working rule, everything is crystal clear. And hope if you understand this video, you know what to do. Please pass it on to your friends, siblings, and the person whom you like the most. And thank you for watching and staying till the end. Go to the playlist. So many videos are uploaded for your preparation. It will be damn easy if you follow those, and your preparation is very, very ridiculous if you follow those. And please pass it on to your friends. Thank you so much for staying till the end.